Hello everybody, good evening to you all. Very warm welcome to Vignan Junior College's channel. Welcome back to chemistry session. I am Aksa, senior faculty in chemistry. Please subscribe this channel. So last week we started classification of elements and periodicity in properties chapter. In that chapter we started different scientists their opinions of regarding classification of elements, right. So we discussed Dobereiner law of triads, Newland's law of octaves, Lothar-Meyer atomic volume curves, different scientists their way of classifying elements. We also studied Mendeleev's periodic table. Then we started long form of periodic table. This long form of periodic table, the main basis for this classification is atomic number. The difference between Mendeleev's periodic table and long form of periodic table is Mendeleev took atomic weight as the basis for classification, whereas Moseley he gave modern periodic law. He took atomic numbers as the main basis for classification of elements. This modern periodic table was given by Niels Bohr, right. So, in this modern periodic table or long form of periodic table, there are 7 periods and there are 18 groups. In Mendeleev's period, how many? Mendeleev's periodic table, how many periods? 7. In Mendeleev's periodic table, how many groups? 9. But in this modern periodic table, there are 18 groups, right. So, out of these 7 periods, first period shortest. What are periods? Horizontal rows in the periodic table. What are groups? Vertical columns in the periodic table, right. So, out of 7 periods, first period shortest only 2 elements, second period short period 8 elements, 2 elements in S block, 6 elements in P block. Third period short period 8 elements, 2 in S block, 6 in P block. Fourth period first long period in the periodic table, it has 18 elements, 2 elements in S block, 10 elements in D block, 6 elements in P block. And fifth period is the second long period in the periodic table, it has 2 elements in S block, 10 elements in D block, 6 elements in P block, right. Next, sixth period, the longest period in the periodic table is sixth period. How many elements are there? 2 in S block, 10 elements in D block, 6 elements in P block and 14 lanthanides, F block elements. The 14 lanthanides should be placed along with lanthanum. So, this sixth period has 32 elements, 2 in S block, 6 in P block, 10 in D block, 14 in F block. Which is the longest period in the periodic table? Sixth period. How many elements are there? 32 elements. And coming to seventh period, it is incomplete period. It has 2 elements in S block, 10 elements in D block, 14 elements in F block and P block elements, they are officially not published. So, we can say that it can accommodate 32 elements, but it is almost incomplete, right. So, this is about classification of elements into periods. Now, I will write like this. So, period, elements, how many elements are there? First period, shortest. How many elements are there? 2 elements. What are they? Hydrogen and helium. Now, I am writing second period, short period. It has 8 elements, from lithium to neon. From lithium to neon. Next, third period, short period. It has 8 elements from sodium to argon. Sodium, potassium, 2 elements in S block, 6 elements in P block. Next, fourth period, first long period with 18 elements from potassium to krypton. First long period, 2 elements in S block, 6 elements in P block, 10 elements in D block, together 18 elements. Fifth period, second long period with 18 elements from rubidium to xenon. Second long period. In these 18 elements, 2 belongs to S block, 6 elements are in P block, 10 elements are in D block. Now I am taking sixth period, longest period in the periodic table with 32 elements from cesium to radon. At least starting element, ending element. Sixth period is longest, 2 elements S block, 6 elements in P block, 10 elements in D block, 14 elements lanthanides. They should be placed along with lanthanum. So 32 elements, longest period. Seventh period, incomplete. Starts with francium. So this is briefly about 7 periods in the long form of periodic table. The main basis for classification here is atomic number. Elements are arranged in the increasing order of atomic number. Atomic number means number of protons. In any neutral species, number of protons is equal to number of electrons. So elements are arranged in the increasing order of atomic numbers or electronic configuration. Now we will see about groups. Right. See here how many groups are there in the modern periodic table? There are 18 groups. Latest IUPAC recommends 1 to 18 numbers for each group, right? From left to right, 1 to 18 numbers should be taken, right? But in old version we have 1A, 2A, like that we have. So first group 1A. Second group, in the old version it is 2A, right? So from now here, see 13th group, this is P block elements, here it is 3A. Then 4A, 5A group, 6th A group, 7th A group, and this is 0 group noble gases, right? So for convenience sake, they are divided into 18 groups. So first group or 1A, second group 2A, from 13th onwards A, right? So 3A, 4A, 5A, 6A, 7A and 0 group. And here this is not 1B, so this should be 3B. Next, this group is 4B, this is 5B, 6th B group, 7th B group, and iron, cobalt, nickel, 8, 9, 10 groups together is taken as 8th group. and this one is 1b and 2b. For objective purpose, we must know that BA like that, otherwise 1 to 18, right. So, this is about classifying groups. How many groups are there? 18. Out of 18 groups, first and second groups, 1A and 2A groups belong to S block. This is S block, right. From 3A to 7A and 0 group, 6 groups are present in P block. Next, 3B to 7B, 8th group has 3 again iron, cobalt, nickel together, 3 groups together, 8th group, 1B, 2B. So, 10 groups they are in D block. The F block elements are placed separately below the table. The 14 elements from cerium to lutetium, they are called lanthanides. The 14 elements from thorium to lawrencium, they are called actinides. So, this is about long form of periodic table classification into periods and groups, right. See, the main basis for this classification is atomic numbers. See, we have discussed just now about groups and periods, right. So, the latest IUPAC recommends 1 to 18 numbers given for groups from left to right, right. Now, in the long form of periodic table, see here which is the shortest period, first period. How many elements are there? 2 elements, hydrogen, helium. See some points here. Which is the shortest period? It is first period. Right, with yellow. So, which is the shortest period? First period. Now, which is the longest period? Just now we discussed. 6th period is the longest period with 32 elements, 2 in S block, 6 in P block, 10 in D block, 14 in F block, right. So, longest period is 6th period. How many number of elements in the longest period will be? 32 elements. Now, which is the longest group in the periodic table? See here. Now, see here the longest group in the periodic table. See the third group, it has 4 elements, scandium, yttrium, lanthanum, actinium, right. Along with these 4 elements, the 14 lanthanides should be placed along with lanthanum. The 14 actinides should be placed along with actinium. So, 14 plus 14, 28 elements should be placed in third group. So, along with that, so 28 elements along with that 4 elements together 32 elements should be accommodated in third group or 3B group. So, now see the question, which is the longest group in the periodic table? Third group or 3B group. Already originally 4 elements are there, 14 lanthanides, 14 actinides. So, longest group, third group or 3B group. Number of elements in longest group. How many elements? 32 elements. Next, which period has only gaseous elements? See, first period has hydrogen and helium. They are gases, right? So, first period has 2 elements, only gaseous elements. Now see here, 7th question, which group has only gaseous element? See, every period starts with, for example, when I take except hydrogen, see from second period onwards, alkali metals. Every period starts with a metal, right, except first period. Lithium, sodium, potassium, rubidium, cesium, francium. So these are all metals. Every period ends with noble gas, all noble gases, right. 18th group elements are all gases. Now see the question, 7th question, which group has only gaseous elements? 18th group. Now see here, 8th question, which period has solid, liquid and gaseous elements? Except first period, every period has solids, metals in the leftmost, right. So these are all metals except hydrogen, all S block elements are metals and all D block elements are metals, all F block elements are metals. In P block, last elements metals, topmost liquid, so non-metals, right. So which period has solid, liquid and gaseous elements? See here, liquid where? Check once. Fluorine, chlorine, gases, bromine, liquid, right. So iodine, solid. So if you see bromine, fourth period has this side solids, bromine is liquid, noble gas. So solid, liquid, gaseous elements, which periods? Fourth period. And one more liquid metal is mercury. See here, one more liquid metal is mercury, right. It is in which period? Sixth period. So this side solids, noble gas is there, this is liquid. So both fourth and sixth periods we have liquids, right. So 8th question, which period has solid, liquid and gaseous elements? Fourth period and sixth period. Actually gallium, it has very less melting point, very high boiling point. It is used as thermometric liquid, but at room temperatures it is almost a solid. At a little bit higher temperatures it exists as liquid. So bromine, liquid, mercury, liquid. Rightmost 18th group gases, the remaining solids. So 6th period and 4th period have liquids, right. 9th question, which group has solid, liquid and gaseous elements? Group, check group. See here, only gas, remaining all are solids. These are all we said solids, right. So now which is liquid? Bromine, right. Fluorine, chlorine, gases, bromine is liquid, iodine, astatine, solids. So 17th group has solid, liquid, gases. So 17th group. Solid, liquid and gaseous elements, right. Last question, which period includes S, P, D and F block elements, right. So first period, actually by definition the helium also should be placed in S block. So second period has S block elements and P block elements, third period has S block and P block elements, fourth periods S, D and P block, fifth period S block elements are there, D block elements are there, P block elements are there. When I take sixth period, it has S block elements, D block elements, P block elements along with F block. So sixth period has S, P, D and F block elements. If you know about these topics clarity, then we can do objective bits, right. Tomorrow we are doing worksheet. So if you know which group, which period, how many elements, what is there, whether they are gas, liquid, solid, right. So this is about when I take seventh period, it has S block elements, 14 actinides should be placed here, D block elements, P is not officially published, so it is incomplete. All 4 blocks are not all included. So, now so this periodic table when we discuss, now it is right. Now, I am taking demerits of long form of periodic table. Till now we discussed how many periods are there, how many groups are there, right. So, which period has only gases, which group has only gases, right, which is the longest period, shortest period, like that we have discussed some points. Now, I am taking demerits or disadvantages of long form of periodic table. The position of hydrogen is uncertain. As we discussed in Mendeleev's table also, position of hydrogen there also is uncertain. It can be placed under, see, hydrogen can be placed under first group elements, hydrogen can be placed under halogens, right. So, position of hydrogen here is uncertain. See here, hydrogen can be placed along with first group elements lithium, sodium, potassium, rubidium, cesium, francium. In some properties, hydrogen resembles first group elements. For example, hydrogen has one S1, just like alkali metals, NS1, 2S1, 3S1, 4S1, it goes on. Similarly, when I take one A group elements, they can lose one electron to attain stable inert gas configuration. So, they can show +1 oxidation state. All first group elements, just like hydrogen, alkali metals can lose one electron, they can show +1 oxidation state. So, in some properties hydrogen resembles first group elements, right, and in some properties hydrogen differs. For example, hydrogen is it is diatomic. In one hydrogen molecule there are 2 atoms, whereas alkali metals they are monoatomic, right. So, some properties hydrogen differs from alkali metals. Hydrogen is non-metal, alkali metals are all metals. So, in certain properties hydrogen differs from alkali metals. Even hydrogen can show -1 state, whereas alkali metals cannot show -1 state. Instead of gaining, they can lose one electron because they have only one electron in the valency shell. So, in some properties it shows similarity with first group elements, but in some properties hydrogen resembles halogens. It can be placed under halogens: fluorine, chlorine, bromine, iodine, astatine. All these elements, they are they have NS2-NP5 valency configuration. So, they can gain one electron, they can show -1 oxidation state. Hydrogen also can gain one electron, especially when hydrogen combines with first and second group elements. Due to higher electronegativity, hydrogen shows -1 state. So, just like halogens, hydrogen can show -1 oxidation state. Just like halogens, hydrogen is diatomic, like F2, Cl2, Br2, H2. Just like halogens, hydrogen is non-metal. So, just like fluorine and chlorine, hydrogen is a gas. So, in some properties it resembles halogens. So, position of hydrogen is uncertain in this periodic table, right. So, we are discussing some disadvantages, demerits of long form of periodic table. Now, you see F block elements, they did not find a position, correct position in the long form of periodic table. See, when I think about F block elements, they should be placed along with lanthanum, but they are placed separately, right. So, they did not find a main place in main periodic table, and though lanthanides have different atomic numbers from cerium to lutetium, right. So, 58 to 71 atomic numbers are different, but they are all placed in 6th period in 3rd group. Similarly, actinides, they are all having different atomic numbers from 90 to 103, but they are all placed along with actinium in 7th period, only in 3rd group 7th period. So, lanthanides, actinides, they did not find correct position in this long form of periodic table. And metals, non-metals, metalloids, they are not given separate places, right. So, these are all some disadvantages of long form of periodic table. Now, we will move to electronic configuration of elements, right. So, the distribution of electrons into various orbitals in an atom, that is called electronic configuration. What is electronic configuration? Distribution of electrons into various orbitals, that is called electronic configuration, right. So, each period starts with NS1, right, and first period helium 1s2, the remaining periods NS2, NP6, they starts with NS1, ends with NS2, NP6, right. So, the distribution of electrons into various orbitals in an atom, that is called electronic configuration. To know this electronic configuration, we must know that Euler diagram. This we might have studied in your lower classes, you might have studied. This is Aufbau principle, right. So, the long form of periodic table, right. So, is the graphical representation of Aufbau principle. What is this Aufbau principle? You might have studied in lower classes, right. Aufbau is a German word, means building up or construction. Electrons enter into various orbitals in the order of increasing energies. What is Aufbau principle? Electrons enter into various orbitals in the order of increasing energies. That means, first low energy level is filled with electrons, then high energy level is filled with electrons, right. See, if you see this energy order, see this diagram, n is equal to 1, first 1s is filled with electron, you have to see like this, right. Next, when 1s is filled with electrons, electron moves to 2s, 2s subshell, after this fill 2p, once 2p is filled with electrons, 3s, then 3p, after 3p not 3d, 4s. See the energy order, after 3p electrons move to 4s, then 3d, after 3d 4p, 5s. This is the order of filling of electrons. S orbital can have maximum of 2 electrons. P sublevel has 3 p orbitals, px, py, pz. Each orbital can accommodate a maximum of 2 electrons. So, 3 p orbitals together 6 electrons, maximum 6 possible. D sublevel, there are 5 d orbitals, dxy, dyz, dzx, dx square minus y square, dz square. There are 5 d orbitals, each orbital can have maximum of 2 electrons. So, 10 electrons maximum can be accommodated in all d orbitals. Similarly, f orbitals, there are 7 f orbitals, total 14 electrons maximum possible. So, you must know this electronic configuration, then only we can proceed how various each period electronic configuration will be observed, right. So, first 1s is filled with electrons. When 1s level is completely filled, electrons move to 2s level, 2s level is filled, electrons move to 2p level, then 3s, After 3s, 3p, not 3d, 4s, afterwards 3d, 4p, 5s, then 4d, 5p, 6s. So, it goes on like this. So, if you see the energy order for various orbitals, so 1s less energy than 2s, less than 2p, less than 3s, less than 3p, right. After 3p, electrons move to 4s. Afterwards, electron moves to 3d level. After 3d, 4p, then 5s. So, it goes on like that. After 5s, 4d, energy order. So, this is Euler diagram, and here also he has shown increasing order of energies. First 1s is filled, low energies, increasing order of energies. So, if you know this Euler diagram, Aufbau principle, we can write different periods how the electrons are filled, right. Now, see, first period, we are mentioning sub energy levels filled in each period. First period 1s, right. First period has one sublevel, right, like 1s. In s orbital, each orbital can accommodate a maximum of 2 electrons. So, 2 elements are possible in first period. Second period has the filling of sublevels, right. So, 2s, 2p, order of filling 2s, 2p, that means 2s, 1 s orbital and 1 s orbital plus 2p, 2p sublevel has 3 p orbitals, px, py, pz. So, 3 p orbitals, together there are 4 p orbitals, 4 orbitals. There are 4 orbitals. Observe here, second period 1s, 2p, they are successively filled. 1s orbital, 3 p orbitals, together 4 orbitals are present. Each orbital can accommodate a maximum of 2 electrons. So, 8 electrons can be filled. So, 8 elements are present in second period. See this point? The number of elements in each period is twice the number of atomic orbitals available, right. So, 4 orbitals are available, twice 8 elements are present. Now, you see third period, what is the order of filling? 3s and 3p, 1s orbital plus 3p orbitals, together 4 orbitals. Number of elements will be twice the number of atomic orbitals available. 4 orbitals available in third period, twice 8 elements are present in third period. Now, I take fourth period. What is the order of filling? 4s, 3d, 4p, right. So, 4s sublevel 1 orbital, p. When I say 3d, there are 5 d orbitals in d sublevel, right. dxy, dyz, dzx, dx square minus y square, dz square. 5 d orbitals available. How many p orbitals are available? 4p, 3. So, together 9 orbitals are available. In fourth period, 9 orbitals are available. So, number of elements is twice the number of atomic orbitals available. So, number of elements in fourth period will be 18. If I take fifth period, what is the order of filling of energy levels? 5s, 4d, 5p. Yes, when I say 5s, 1 orbital. When I say 4d, 5d orbitals. Then 5p, 3p orbitals. Here also 9 orbitals are available. How many elements possible? Twice the number of atomic orbitals available. 9 orbitals are available, filling, then twice. So, 18 elements are present in 5th period. If I take 6th period, see here, what is the order of filling? 6s, 4f, 5d, 6p, right. 6s when I say 1 s orbital, 4f, there are 7 f orbitals, then 5d, 5d orbitals, then 6p, 3p orbitals. Together 16 orbitals are available. We have just written what is the order of filling in each period. How many orbitals are available? 16 orbitals are available in 6th period, twice the number of orbitals. 32 elements are possible in 6th period, right. So, similarly like 7th period, 7s, 5f, 6d, 7p, 32 elements theoretically possible. So, this is about how the sub-energy levels are filled in different orbitals, and then like how many elements possible in each period. First period 2 elements, second period 8 elements, third period 8 elements, fourth period and fifth periods, first long, second long periods 18 elements. Which is the longest period in the periodic table? 6th period. How many elements? 32 elements. How many orbitals available? 16. 1 s orbital, 7 f orbitals, 5 d orbitals, 3 p orbitals, right. Next, 7th period also theoretically 32 elements possible. So, period number corresponds to the main energy level, shell number, right. When I say 1s, first period, n is the principal quantum number. When I say 2s, n is equal to 2, principal quantum number, it indicates the size of orbit, orbit number. When I say 3s, third main energy level, n is equal to 3, right. So, each successive periods associated with filling of next higher principal energy level. See, first 1s is filled, next period successive filling of 2s, 3s, it goes on. First period starts with filling of lowest energy level, L shell, right. So, we are now writing about how the energy levels are filled, right. In the first period, we have hydrogen, helium, 1s1, 1s2. First period 1s, only one s orbital available. It can have maximum 2 electrons. So, 2 elements are possible, 1s1, 1s2. We are representing electronic configuration, right. Now, I am taking second period, this is K shell. Now, you see second period, it starts with, second period starts with lithium, ends with neon, right. So, when I say lithium 2s1, it starts with filling of s orbital, and at neon 2s2, 2p6. That is the filling order, right. So, next third period K, L, M shell, third period, it starts with sodium, ends with argon. Sodium means it starts with 3s1, argon 3s2, 3p6. So, first period only 2 elements, second period 8 elements, third period 8 elements. Next, fourth period starts filling N shell, potassium to krypton, 4s1, 4s2, 4p6, right. So, before filling 4p, in the fourth period we have, before that we have 3D level scandium to zinc, right. So, 10 elements scandium to zinc, 10 elements are filled in 3D level, right. Next, fifth period starts with rubidium, ends with xenon, 5s1. Before starting xenon 5s2, 5p6, 4d is filled. Just now we discussed. In the fifth period, order of filling is 5s, 4d, 5p. So, 4d level is filled, means yttrium to cadmium. Like that, 10 elements are here, then xenon 5s2, 5p6. Next, the sixth period, cesium to radon, 6s1. What is the order of filling in sixth period? 6s, 4f, 5d, 6p, right. 6s, 4f, 5d and 6p, 6s2, 6p6. So, this particular order they are filling, S can have 2 electrons, F maximum, I mean maximum 7 orbitals are there, 14 electrons, D, 5D, 5 orbitals are there, 10 electrons possible, P, 3 orbitals, 6 electrons possible. So, this is just the order of filling. Next, seventh period also we have francium onwards, 7s1. After 7s we have 5f, 6d, 7p. So, that is the order of filling of different energy levels, right. Now, we will take some next. You see, elements in each group have similar valency configuration, right, similar properties, same number of electrons in the valency shell. Each group elements have similar properties. When I take alkali metals, lithium, sodium, potassium, rubidium, they all can form monoxides, right. So, M2O. Lithium can form monoxides, sodium and others they can form peroxides, potassium can form superoxides. Certain properties similar, they form similar types of hydroxides, MOH. They form similar type of halides, MX. So, in each group properties will be similar. Why? Because they have similar valency shell configuration, similar number of electrons in the valency shell. In every group properties are similar, but in each period properties gradually changing. Now, see this question, how would you justify 18 elements in fifth period of periodic table? Justify, how can we say there are 18 elements in the fifth period? Order of filling of energy levels in fifth period. Tell. 5s, 5s, 4d and 5p. What is the order of filling? 5s, 4d, 5p, right. So, total number of available orbitals, when I say 5s, yes, 1 orbital, d sublevel there are 5 orbitals, p sublevel there are 3 orbitals, total 9 orbitals available, right. So, order of filling is 5s, 4d, 5p. How many total orbitals available? 1 plus 5 plus 3, 9 orbitals available. So, number of elements will be double to the number of available orbitals. So, 18 elements are possible in 5th period, like that we can calculate. To find the group number and period number in the periodic table. It's very interesting question, very important for objective purpose also. How to find the group number and period number in the periodic table. Observe here, first whenever he gives one element, write the electronic configuration. How to write the electronic configuration? It is known by, if you know that Euler diagram, Aufbau principle, different, first low energy level is filled, then high energy level is filled. If you know how to write electronic configuration, then we can tell this element where it belongs to, I mean which group and which period it can be placed, right. So, first write the electronic configuration of elements. Then how to know the period number? Maximum value of n. N is the principal quantum number, right. So, when I say 2s, that is second period, n is equal to 2. When I say 5s or 5p, n is equal to 5. So, last shell, what is the principal quantum number? That is the period number. Maximum value of principal quantum number n, that indicates the period number, right. So, how to know the group number? For S block elements, number of electrons in ns sublevel, right. So, for P block elements, number of electrons in ns plus np electrons plus 10. You have to know the group number means for P block elements ns plus np plus 10. For D block elements, number of electrons in ns plus n minus 1 d orbitals together, right. Then for F block, how to know the group number of F block elements? They are all placed in third group, the longest group in the periodic table, third group or 3b group. This includes all F block elements, right. So, for S block, ns electrons, for P block, ns electrons plus np electrons means valency electrons plus 10. For D block, ns electrons plus n minus 1 d electrons. F block, which group they belong to? Third group. So, we must know this concept, then we can apply, right. Now, I am taking one example. See this question? An element has atomic number Z is equal to 17. Find its group number and period number. An element has atomic number 17. First what we said? Write the electronic configuration. When I say Z is equal to 17, Z is equal to 17. Write the electronic configuration. 1s2, 2s2, 2p6, 3s2, 3p6. How to know the period number? Last shell, maximum value of n, right. So, maximum n value, n is equal to 3 here, right. So, this should be in third period. So, how to know the period number? Maximum n value. So, it should be in third period. How to know the group number? He has given 3s2, 3p6, that means it belongs to P block. Sorry. When I say 17, 10 plus 2 plus 5, sorry. Ten plus 2 plus 5, it is 17, right. When I say 3s2, 3p5, it should belong to P block, right. So, P block, how to calculate group number? In P block, group number is equal to, how to write group number? ns electrons plus np electrons plus 10. We must know this formula, ns electrons plus Np electrons plus 10. So, group number Ns electrons 2, valency shell Np electrons 5 plus 10. So, total will be 17. That means it belongs to 17th group. Period number, third period, group number 17th. So, group number is equal to 17. Third period, 17th group. That means it should be fluorine, chlorine. Chlorine is group number 17, period number 3rd. Our 17th, Z is equal to 17 element should be chlorine, right. So, how to know the period number? Maximum value of N. How to know the group number? For P block, Ns electrons plus Np electrons plus 10. Now, we will take one more question. In terms of period and group, where would you locate the element with Z is equal to 114, right? See, bigger atomic numbers are given. What we have to do is, first by heart noble gases. Observe here, helium, neon, argon, krypton, xenon, radon, organosine, if it is discovered, right. Next, 2, 10, 18, 36, 54, 86, difference 2, add 8, 8, add 18, 18, 32, go on adding 32. So, it should be 118, right. So, I sincerely advise you to by heart these atomic numbers 2, 10, 18, 36, 54, 86, 118. First period, second, third, fourth, fifth, sixth, seventh period, right. Now, see the question, in terms of period and group, where would you locate the element with Z is equal to 114? See here, 86 is radon. I am taking a radon core, means 86 electrons are in the inner shells. Core means inner shells, right. 86 electrons are over. 1, 2, 3, 4, 5, 6th period is over. Now, I am writing 7s. In the 7th period, what is the order of filling? Just now we discussed 7s, then 5f, 6d, 7p. We must know the order of filling. If you know that molar diagram, we can know 7s, 5d, 5f, 6d, 7p. S can have maximum 2 electrons. F can have maximum together 14 electrons. D can have together 5 d orbitals together 10 electrons. 86 are inner shell core. Now count 86, 88, 98, 100, 102, 112. Then how many remaining? 2 are remaining, 114. By heart noble gases we can easily write, right. So, 86 is over, then 7s, 5f, 6d, 7p. So, once you know this, our valency shell 7s2, 7p2, which period now? Maximum N value is 7. So, what is the period number? Period number is 7. What is the group number? How to calculate? Ns electrons plus Np electrons plus 10. So, how to calculate group number? Ns electrons plus Np electrons plus 10. 14th group, 4th A group or 14th group, 7th period, 14th group. This particular element 114 should be in 7th period and 14th group. So, you should usually by heart these noble gases, right. So, I am taking like this, 118 is noble gas, 117, 116, 115, 114. So, this should be here, 118 is 18th group, 114 should be 14th group. So, if you by heart, suppose he says where is 34, 36 is noble gas, 35, 34, 18th group, 17th group, 16th group. So, 34 element should be in 16th group. In which period it is? 1, 2, 3, 4th period. So, if you know the noble gases, if you by heart their atomic numbers, we can with respect to this, where is our new element, right. Now, see this question, write atomic number of the element in the 3rd period and 16th group in the periodic table. 3rd period, 16th group. So, period number, third period, group number, 16th. He has given group number also, right. When I say 16th group, we must know that it belongs to P block. First and second groups, S block, from 3rd to 12, 10 groups in D block, from 13th to 18th, right. So, when I say from 13th onwards, you must know that it belongs to P block. When I say 3rd period, period number he gave, group number 16. So, in P block, how to know the which period position for P block? Observe here, how to calculate group number? Ns electrons plus Np electrons plus 10. So, Ns electrons plus Lp electrons plus 10 together is equal to 16. He gave group number. So, I am writing like this, Ns electrons plus Np electrons plus 10 is equal to 16. He gave group number 16. So, Ns electrons plus Np electrons is equal to 16 minus 10. I brought this here, right. So, 6. S can have a maximum of how many electrons? 2 electrons S can have. So, 2 plus Np electrons is equal to 6. So, Np electrons is equal to 6 minus 2, 4. That means S orbital has 2 electrons, P orbital has 4 electrons. Now, you write. So, this is 3rd period, 3s2, P orbitals, how many electrons? 3p4. This is the outer shell. What is the inner shell? 1s2, 2s2, 2p6, 10 plus 6. So, 16 electrons are there. So, that means 16th element in the periodic table. What is that element? It should be sulfur, oxygen, sulfur. So, write the atomic number of the element in the 3rd period and 16th group in the periodic table. How to know the period number? He has given 3rd period. When I say 16th group, we must know that it belongs to P block. From 13th to 18th groups are in P block. So, for P block, how to calculate group number? Ns electrons plus Np electrons plus 10, right. So, see, we have calculated like this. S can have maximum 2 electrons, P can have, we have calculated. So, it should have N3s2, 3p4. So, in the next class, we will continue. So, up to long form of periodic table and electronic configurations of different elements, how to write, we have discussed in this class. Tomorrow, we will try worksheet. So, please join tomorrow also. So, thanks for being with us. Please subscribe this channel.